Okay, so the next thing I want to talk about, this is an important concept we'll come back to at multiple points during 221 Lab, are dilutions. So dilutions are where we are diluting the concentration. We're making a concentration which is lower. And we do this many times, particularly for spectrophotometry, which we cover this week in the DNA isolation lab, where if our concentration is too high, our instruments are not able to measure that successfully, so we need to do a dilution. And we'll come back to this as well with some of the colony forming units with bacteria in a couple of weeks. So let me give you an example of a dilution. So we'll go back to our chemical before, our solution before, where we have our concentration, which is 1 milligram per milliliter. And remember, that means we have 1 milligram within our stock concentration. So say we want to do a dilution, we want to make it so it's less concentrated. So if you imagine making something with a lower dilution, you're making it less concentrated. There'll be less mass as a function of volume. So we're going to do a second tube here, and then we're going to take a portion of this and transfer it into a new tube, which has what's called a dilutant in it. And this is usually something like water. So what we want to know is, how does the concentration change between these two tubes? So this depends upon how much volume is in here, the volume of the dilutant, and how much transferred volume you take. And the way we can calculate this is using the dilution factor. The dilution factor is total volume of the second tube divided by the transferred volume, which is this one here. Now, what's really important to remember is the total volume is comprised of two things. It's the dilutant volume plus the transferred volume, and I'll show you that in a moment. Okay, so let's do a simple example. We'll set this up again, where we have 10 milliliters of our stock, which is at 1 milligram per milliliter. And then we're going to put it into a new tube, which has 9 milliliters of water in there. So we're going to transfer from our stock, from our concentrated, 1 milliliter into our new tube. Okay, and that's going to go into our 9 milliliter, and we're going to mix this up. So to calculate the dilution factor, we are first, if you remember, we're going to take the total volume over the transferred volume, and by total we're talking about this tube here. As I mentioned, the total volume is the dilutant, in this case 9 milliliters, plus the transferred volume. So don't forget, this is something that people forget, is this total also includes this transferred volume, so plus 1 milliliter. And that's going to be over the transferred volume, which is 1 milliliter. And if we calculate this out, we're going to get 10 over 1, which gives us 10. And what this means is we have a 10-fold dilution here. There's a 10-fold dilution. This is 10 times less concentrated than this one here. And quickly we can calculate that out. So if we want to know the concentration here, it's going to be 1 milligram per milliliter divided by 10, which is going to give us 0.1 milligrams per milliliter. So this new volume is going to be 0.1 milligrams per milliliter. So anytime you have to calculate the concentration of a dilutant, first thing you need to do is calculate the dilution factor, and then divide that by the dilution factor. So if this was a 100-fold dilution, then you would divide by 100. Let's do one more example. So this one should look familiar. So say you have your tube of extracted DNA, so this is 50 milliliters, and you take 5 microliters out of the tube and put it into 495 microliters of dilutant. So I said this can be water. It can also be something like TE buffer, which is something we use during our DNA measurements, our DNA concentration measurements. So again, we do our dilution factor. That is going to be the total over transferred, and the total being 495 plus 5, which is 500, over 5, our transferred volume. So that's going to be 500 divided by 5. And if you work that out, that's going to be a 100-fold dilution. So again, if we know the concentration of this, say it is, well, actually, let's do it in the opposite direction. So if we're going in this direction, so concentrated to dilute, we're going to divide by the concentration factor. Or I'm sorry, divide by the dilution factor. If we're going to go, if we have a concentration measured here, then we're going to multiply by the dilution factor. So say, for example, your readout from this gives you 2 micrograms per milliliter. In this case, you would take this and multiply it by the dilution factor. So 2 times 100 would give you 200 micrograms per milliliter. And that would give you the concentration of this. So with these, the trick is calculate dilution factor using this. And then if you want to calculate the lower concentration, you're going to divide the original concentration by the dilution factor. And if you're going in the opposite direction, where you have the concentration of the diluted volume, then you're going to multiply by the dilution factor, and then that will give you the concentration of the stock concentrate.